Okay, so now we're going to go over the section on indeterminate forms, and I've got 5 problems that we're going to go over, and there are going to be 5 problems on the test as well. Okay. So problem number 1, let's say the limit as x tends towards 0 from the right of x to the 7, now multiplied by the natural log of x. Okay? Now, this is of the indeterminate form. As x tends towards 0 of x to the 7, this term is tending towards 0. But as x tends towards 0 from the right of the natural log of x, this is tending towards negative infinity. Okay? So we have something that looks like 0 times infinity. Right? But we want to do L'Hopital's rule on this. But you have to remember that L'Hopital's rule only works if you have a fraction that is of the form 0 over 0 or infinity divided by infinity. So what we're going to do is we're going to force this to become a fraction so that we can then apply L'Hopital's rule to it. Okay, so that would be the limit as x tends towards 0 from the right of the natural log of x divided by 1 over x to the 7th. Now, L'Hopital's rule does not care if you're going to plus or minus infinity. But at this point in the problem, this guy is headed towards negative infinity, and since it's headed towards the right, this guy is headed towards positive infinity. I don't really care if they're negative or positive. Let's just go ahead and let's apply L'Hopital's rule to this. So the derivative of the natural log of x is just 1 divided by x. Right? Now, if we're taking the derivative of 1 over x to the 7th, you need to think of this as x to the negative 7 power. Okay? So since this is x to the negative 7 power, what's it going to do? It's going to spit out a negative 7, and it's going to drop it down to negative 8. So this would become negative 7 divided by x to the 8. Okay. This next step is not completely necessary because normally when I think about this problem, I just think, oh, I'm going to flip those fractions upside down. But if you want to do it, think about it this way. What would happen to this problem if I multiplied by x to the 8 divided by x to the 8? That would be the limit. Now as x tends towards 0 from the right, scoot you up a little bit. Now x to the 8th divided by x. Okay, so x to the 8th over x is just x to the 7th. And x to the 8th divided by x to the 8th is going to cancel each other out, and so we're just divided by negative 7. And at this point, the problem you say, hey, that's going to 0. Okay, it's 0 divided by negative 7, so it is just 0. Okay. Okay. So let's say we had the limit as x tends towards 0. Now we have e to the 2x minus 1 divided by sine of x. Okay. All right, so we're going to look at L'Hopital's rule on this thing. E to the 0 is just 1. So what does the top of this problem look like? The top looks like 1 minus 1. Okay, so the top is going to 0. And sine of 0 is also 0, so this thing is of the form 0 divided by 0. So I would say this goes to 0, that goes to 0. That's going to equal the limit as x tends towards 0. Now, the derivative of e to the 2x is e to the 2x now times 2. And the derivative of negative 1, well, that's just 0, so it's going to go away. All right, and now we have to consider, oh wait. Normally on a test, I tell students that if they either write 0 over 0 or L'Hopital's rule, one or the other, I'm going to take it. But if both are missing, then I take off because I don't know when you're doing what step. So anyway, so now we're going to take the derivative of sine. The derivative of sine is going to be cosine of x. Okay, e to the 0 is just going to be 1, and cosine of 0 is also 1. So this becomes 1 times 2 divided by 1. Well, the answer just comes out to being 2. That was a relatively short one. Go on to the next one, let's say the limit as x tends towards infinity of x squared divided by e to the 4x. Okay. This is one of those L'Hopital problems where we're going to have to do L'Hopital's rule more than once. So that tends towards infinity. That also tends towards infinity. So go ahead and apply L'Hopital's rule. That'll be 2x divided by e to the 4x times 4. Well, it's still infinity over infinity. So we're going to have to apply L'Hopital's rule again. But that would be the limit as x tends towards infinity. All right, 2x is just going to be 2. When we take the derivative of e to the 4x again, it's going to spit out another 4. So that's e to the 4x times 4 squared. Now this is a constant divided by infinity, so if we have a constant divided by infinity, that is just going to go to 0. 2 more to go. Okay, so the limit as x tends towards 0 from the right of x raised to the square root of x. Okay, so we're going to have to do a logarithm on this problem to actually evaluate this limit. Okay, so we're just going to say this equals out, and we're going to take the natural log of this and try to evaluate that, and then determine the limit afterwards. So the natural log of L would equal the limit as x tends towards 0 from the right. All right, so the natural log will allow us to pull that square root to the outside. Okay, we still want to do L'Hopital's rule on this thing. So it's very similar to the first problem that we did. Okay, we're going to have to force this to become a fraction. So that's the limit as x tends towards 0 from the right of the natural log of x, and 1 divided by the square root of x. All right, so that is tending towards negative infinity. That is tending towards positive infinity. We don't care if they're negative or positive. So we are going to apply L'Hopital's rule to this problem. And that's going to be the limit as x tends towards 0 from the right. The derivative of the natural log of x is 1 over x. Okay? Now, the derivative of 1 divided by the square root of x. You can think of this as x to the negative 1/2 power. Okay? So, negative 1 over 2, and this would be x to the negative 3 over 2. And this is entirely necessary, but if you want to think about this in terms of multiplying by 1, I'm trying to get that x to the negative 3 over 2 off the bottom. Okay. And then on top, all right, all we are left with on the bottom is the negative 1/2, and at the top is x to the 3/2 divided by x, so let's put this x to the 1/2. So, the limit as x tends towards 0 from the right of x to the 1/2 divided by negative 1/2. And you'll notice, like on the previous problem, that I ended up with an x to the 7 divided by negative 7. That's a common thing. It's going to keep happening. So, and the reason for that happening is the fact that what happens when you force something down to the bottom and you take its derivative, it subtracts by 1. Okay? But then when you put it back on top, it's divided by x. So that's the reason that keeps happening. Okay, well, you're not done. Yes, you can say that equals 0. Okay, but this is one long statement right here that the natural log of L is equal to 0. So if the natural log of L equals 0, and we raise both sides above e, that's going to imply that L is going to equal e to the 0, which equals 1. All right. Last problem. The limit as x tends towards 1 of x squared, that's squared, minus 1 divided by x to the 5th minus 1. All right. Now, the top of this problem looks like 1 minus 1. The bottom of this problem also looks like 1 minus 1. Both of them are going to 0. So, that's going to 0. That's going to 0. This is going to equal the limit as x tends towards 1. Okay, so the 1s are going to go away because they're derivatives of constants. This is going to become now 2x divided by 5x to the 4th. Okay. Well, at this point of the problem, you don't have 0 over 0 in this at all. You can plug 1 into this thing. 2 times 1 is just 2, and 5 times 1 to the 4th power is still just 5. So, the answer to the problem ends up becoming just 2 divided by 5.